Okay, so number 11, because the numerator has a exponent that is higher than the denominator, you have to divide it. And so you just have to multiply this times x to get x cubed. And so the remainder is negative x. So you subtract x over x squared plus 1. And so then you're taking the derivative of that. Oh, integral of that, sorry. Oops. That's what I meant. I keep losing where I am. So I separated it because it makes more sense. And so this one is just really easy. It's just 1/2 x squared. So I just left it as is and went over here. And so I set u equal to the denominator. Can you see it? And so we're missing a 2. Yeah. So from there I just changed everything to use.
I bet you're looking for cans.
What?
My chemistry teachers always know where to find cans.
Okay.
I'm pretty much famous. Yeah.
And so I just put everything together. And this one is just the ln rule. So, and so it's normally the absolute value of u, right?
Yes.
But in the book it had parentheses.
And the only reason is because it would be x squared plus 1, which is already positive. So sometimes they'll drop it if they know it's positive.
But I
You
can
would not
put
be wrong
absolute
if you
value.
could.
Okay, cool. I'm going to put absolute value.
Yeah,
And I just substituted in u already. Yeah.
Can you explain that in the video?
What?
The explanation as to why in the book. Actually,
You're good. It's
Okay.
okay. Any other questions on homework? Hello? That I put in the wrong month is April. Did I put in the wrong day?
you just said you need to spell
No, sorry. It's April 12th and 13th. April 12th and 13th. Yes. Thanks. I also would kind of like an HL format sheet. I was just going to point out the rule to y'all. Well, what you missed was a nice phone call. We thought we paused it. Anyhow, so here on this one, it looks a lot like arctan, and the reason is this is like 1 squared plus cosine x squared. And what do you think the sine is going to be part of? Yeah, it's your du. Okay, so that's what you're trying to recognize there. So I'll just kind of write this rule off to the side to kind of remind you. Pretend you can tell that's an A. Are you using your imagination today?
I am.
So 1 over A, I'll move the paper just a sec. Arctan x over A plus C.
Did I say 1 over a squared plus x squared?
Yes. That was the imagination part. Okay. All right, so for us, what would A be?
1.
And what are we going to use for U?
X. Oh, it's cosine squared.
Just cosine x, because it's whatever
Yeah, you're right.
you're going to square.
Yeah.
Do you? Okay, and so I almost have that. And so this would be -1, and if you want to rewrite it, this would be du over, you want to put 1 squared or a squared? Okay, so a squared plus u squared, which is exactly our rule. So it would be negative 1, and then 1 over a, which is just 1 over 1, so I'm just not going to write that. And then arctan x over a, so that'd be u over a, so cosine x over 1, which is just cosine x. And we're supposed to do that from pi over 2 to pi. And that's definitely not going to scare us. We'll leave the negative 1 out. So this would be arctan of cosine of pi minus arctan of cosine of pi over 2. And so when you think about where pi is, it's right here, negative 1, 0. So what is the cosine of pi? So this would be arctan of negative 1 minus arctan, good. Okay, so the question is, what's the arctan of negative 1? I want an angle. So when you look at arctan, you're looking in the first and the second quadrant. First and fourth quadrants. That's where the answers are supposed to come out. So if you go right here, what is it? What's this point right in the middle? Yeah, this is pi over 4, square root 2 over 2, square root 2 over 2. You're actually going to say you're going to say negative pi over 4. If you were, you're supposed to do, remember how you're supposed to be a 1-to-1? So you're not wrong that in this quadrant, 3 pi over 4 does have a tangent of negative 1, so you're not wrong about that. But when they try to make it, remember how they make it a 1-to-1, and they try to limit the domain? So they limited it between negative pi over 2 and pi over 2 for arctan. So when they took like what arctan looked like, or this is what tangent looks like, and it keeps going. So if we took the inverse of it, this doesn't pass the horizontal line test, but it passes the vertical line test. So what, if you remember, they restrict the domain. Just trying to look for a highlighter. So they restricted the domain of this just to be between negative pi over 2 and pi over 2. And so that way that becomes the range of the arctan. So you're only supposed to look for the answers between there if they just ask you arctan of negative 1. Now there can be situations where you want to know all the angles whose tangent is negative 1, and then I would include the 3 pi over 4. But that's why I'm going for this one, is you're supposed to look between first and fourth quadrants. So this guy is like this. Okay, so negative pi over 4. And if you do it on your calculator in degree mode, it'll give you negative 45. So, I mean, if you have your calculator, you can do that, but you are supposed to know it and expected to know it without a calculator. But this one's a little easier. The angle whose tangent is 0. 0. Okay, so then you just get pi over 4. Okay, anything else on the homework? I was afraid you were going to say that. It's a good choice. It's just a little gross. Can I move this? Yes, no, maybe? Good now? Okay. This has some miscellaneous junk, but it's still got a lot of clean space, so we'll do this. 25. Is this the last one? Try to encourage me. Okay. Okay, either they gave you a clue or I gave you a clue or both. Okay. Alright, so this was the clue. Any thoughts on what it might turn into? Yeah. It's probably an arc sine because this is like 1 squared minus the square root of x squared under the square root. Okay, so u is the square root of x. What would du be? Okay, which could also be written as like this. True. Okay, do I have a lot of that? Okay. Okay. So I've got all of this, but I need the 1/2. So I need a 1/2. What would that make on the outside? Okay, so if I rewrite this, it would be 2, the integral of, and actually this is part of the du now. So all of that's du over the square root of 1 squared minus square root of x squared, or u squared, however you want to look at it. Okay, so I kind of need my arc sine rule. Now, there's certain rules. Yeah, because this is x, so u is the square root of x, so if you square both sides, u squared would just be x. So instead of that x, I'm putting u squared. Yeah. How to take what? So all of this that I have circled in red, including the 1/2, is du. So instead of all that, I put du. I didn't take it out. This is equivalent to du. It's the same thing. So this equals du. So I put du instead of all that stuff. Now the only thing I put was like the 1/2 and the 2. Alright, he's still thinking about that. He might ask me something else in a minute. Alright, so this little rule, I'll write it to the side. So it's arc sine x over a plus c. Okay, so for me, it's basically just a is 1 and x is u. Okay, so I don't need the integral anymore, actually. This would be arc sine of u. And then you just put back in what the u is. So it's actually kind of sleek. It could be awful, like if you decide to solve this for x and dx, then the algebra could be a little tedious, but if you can tell that that's most of your du, it makes it not too bad. Is that enough on the homework? It feels like enough. Okay, so this is probably one of the hardest lessons for the 2 years. Okay, but some of it is going to seem simple. Okay, now what this is, I cut and paste this from your textbook, so it's in your textbook. And it's trying to give you some helpful hints on substituting. You know how like the hardest part is sometimes figuring out what u is? This is like kind of a cheat sheet for that. But here's the good news. These trig substitutions, which are not the first ones I'm going to do. Okay, I'm going to do some of the substitutions you're already kind of comfortable with first. But I'm like 99.99% sure if you ever have to do these, they give you the u substitution. So every HL problem that I've seen where in the question banks and on every test that's since I've been doing HL, they give you the substitution. They don't make you figure it out if it is a trig substitution. So I'm confident enough to tell you, hey, they're going to give you that. Okay, so really, you're kind of familiar. Usually if you have something to a power, then that's what you pick for u. So having square root of something, then that's kind of telling you whatever's under the square root, that's probably going to be your u. Okay, if ln of x is there, they're just saying it's usually a good idea for that to be your u. Now, these others would be difficult for me to figure out, like what trig substitution I would need for these. Except they look a little bit like the inverse trig rules. Like if you think about the integral for tangent, it is the 1 over a squared plus x squared for arctan. So that's like, if I was trying to do it from scratch, that would be like a little bit of a clue that the x squared plus a squared is going to be a tangent substitution. And then this is just kind of similar to it. The sine one, if you notice, this is like the square root of a squared minus x squared, and it's the sine one. So that's a little bit of a clue on your formula sheet that this is going to be a substitution. This actually looks like the secant one, but you don't have the secant rule on your sheet. Okay, but again, I'm not too worried about that because every single test question, including the test that I'm going to give you that the seniors are warning you about, you're given the substitution that you need for these. Okay, the deal is for these, I'm going to tell you this right now even though you have no context for this, if they tell you that it's a trig substitution, okay, and they'll give it to you, then you need to draw a triangle. You just need that in your mind right now. If you don't draw a triangle, and I'm going to show you what that means and what you get from it and what you can finesse from it, but on the test, and I told them this afterwards, but see, every time a class messes up, it gives me something else to tell the next class to try to keep them from messing up. Okay, so the goal is not that every time I have a certain test, everybody does poorly. If they do poorly, then I'm trying to figure out why did they do poorly, and what can I communicate to you so that the next group does not do poorly. Does that make sense? Okay, so my goal in life is not actually for you then to tell next year's class, oh, you're all going to fail this test, except for whoever it is in this class that doesn't. Okay, so my goal is that, in fact, you are not going to fail the test, that I'm going to learn from whatever they did, and I actually asked certain people, like, okay, what if I had talked about this more? What would have made it where you knew how to approach this problem? Okay, so I'm not going to fail the test. We're gonna do well in the test. Well, it was a different test. Like, they move around. Like, it's not always the same. So everything for them practically was new. And then the year before it wasn't all that new, but the year before that everything was new. So it's like stuff moves around. Yeah. We try to improve. So some stuff gets recycled, some stuff gets improved. We do a little soldering and stuff like that. Try to make it better. Okay, because if I just do the same thing, then I'm going to get the same thing, right? So I don't want to do that. All right, so that being said, we're looking at this problem, and this is not a problem where they would give you what the substitution is, but they do give you a substitution for trig ones. Okay, so just looking at this, what do you think would be a good idea for a u substitution? X plus 1, because it's what's under the square root. Okay, now we would really love it if du was on the outside, but what's du? Yeah. And remember that any time you either have an x that you don't need, or you need an x and you don't have it, then that's the method I already taught you. Okay? Solve for, well, I'm already solved for u. I need to solve for
x using.
Yes. So I need to solve this for x and this for dx. So this would be just u minus 1, and this doesn't change. Okay, and then you just rewrite it. Okay, so this is not anything new. It's just you got to kind of keep recycling these because they just throw everything at you together. So you got to kind of know, okay, what have I got in my bag of tricks? All right, so right here where it says x squared, I know what x is, so I'm going to put in u minus 1. And then I need to substitute in for this. Now this is where we're talking about a little bit of finesse. Okay, this is a tiny bit. It's not like our real finesse, but it's like a tiny bit of finesse. Okay, so if you see this is the square root of x plus 1, what would be like the sleekest way to change that over? U to the 1/2. Okay, now you're still going to get it if you put in x as u minus 1. You're going to get u minus 1 plus 1, which is u. And then it'll be the square root of u, which is u to the 1/2. But if you already notice, hey, that's already what I had for u, then it just saves you a little bit of less likely to mess up. And then dx is du. Now you got to watch out when they're not just equal, because that usually ends up being some problems. Okay, suggestions. We did all the hard substituting. Foil it out. Good. All right, so what would that be when I foil it? Perfect. And then we're just going to distribute the u to the 1/2. It's just going to be power rule. This is like almost too easy for you. Here I am saying it's going to be a hard lesson. It will be, but not yet. Okay. All right, so when we multiply, what do I do with my exponents? Add them. So 2 plus a half, how could I make that? 5 over 2. That sounds good. Okay, and then the next guy. Yeah. And then the last guy. You know what's going to be funny is when y'all do really good on this test and you can just laugh at the seniors. It'd be like, you guys had trouble with that? Please. Yes. That'd be pretty sweet, you have to admit. Wouldn't it? Really? Where's your confidence? Alright, here we go. So this is just power rule. Help me out. I'm just going to leave the 2 there. U to the 5 halves, so that'd be 2/5. I just like to do the exponent first because that's what I'm flipping. So, because I don't want to do it all at once because I find I make careless errors when I do. Alright. So, and I will say some people here can do it and get it right. And some people in here think they do it all right, and then they get to the test and they take shortcuts and it kills them, even though they like intuitively understand everything. Just saying. Okay. Got no problem with intuition. Sometimes it's the simple, tiny little things. All right, so add 1 to the exponent. Reciprocal. Okay, now in the last step, all I have to do is substitute in for u, and I will go ahead at the same time and simplify all that. So this would be 2/7, put in your u as x plus 1. And now I can satisfy David and put 4/5, x plus 1 to the 5 halves, plus 2/3. Yep. That wasn't so bad. Like, it looks kind of fancy, like we're pretty smart folks. But, I mean, that's not so bad.
I'm glad we were able to learn the entire lesson by doing this one problem so we don't have to do the rest of the lesson.
Remember the astute student you aspire to be?
If you look at my answer, it matches yours.
Alright. How do you think I'm going to start this one?
Pretty much the same way.
Yeah? So if it's pretty much the same way, you probably don't need me. You probably need to take a minute and try it. Alright, so it turns out this one did have a few twists and turns. So, tell me how you started.
U equals 3 minus x squared.
Okay, then what? Okay. Okay, so you decide to solve this for x because that's what I taught you, although I'm going to promise you, or I'm going to do something different. Okay, so u minus, oh, I got to go the right way. Alright, so I'm just going to go ahead, I'm going to say what x squared is too, is that okay? That might be useful. That's a little gross and could cause me some problems. I'm going to do some finessing. What about dx? You got that x too. That x is actually going to work to my advantage. Okay, so I'm going to try to substitute in. Now, I'm going to be a little sneaky. I don't know if you want me to be, how sneaky you want me to be. So I could wait and do the x cubed, because if you look at dx, one of the x's cancels. Or I could try to do it right now and just do it like this times this. What are your thoughts?
Let's do it this size one.
The x squared times x? Would that be okay?
Why would you do x squared times x?
Well, because the x is going to cancel.
Me and Max did it in different ways. Yeah, we did completely different ways, but we both got the answer.
Okay. Well, do you have suggestions? I'll tell you, I left the x cubed to start with. And then, what's this square root of 3 minus x squared business? So that's the square root of u, and then my dx was du over negative 2x. Now, I can't be done till I replace all the x's with u's, but I canceled one of the x's, which makes the algebra a lot easier. So one of these x's can cancel. It'll still work if you don't do that. It's just, so this would be x squared. We'll see. So what do we got? Du over -2? Okay, by the way, that's x squared. Can you tell that? Let me just... Okay, so instead of x squared, I can put 3 minus u. And what do you think about the u? And what do you think about that -2 in the denominator? Let's take that out of there. Okay, and then that's going to be easy. All right, and I'll let you put yours under the screen afterwards and just like talk through it, because we got to do like the super hard stuff today. Okay, so minus u to 3/2. And again, there can be different, that was kind of finessing because I got around some of the weird algebra by doing that. If you hardcore go through the algebra, it should still work. So we have -1/2, and then leave the 3, add 1 to the exponent times the reciprocal, add 1 to the exponent times the reciprocal. I'll cancel those 3's. And what I'm thinking is I'm going to just go ahead and distribute the -1/2 and put in what u is. Is that okay? Should I pause? Okay, so if we distribute the -1/2, -1/2 times 2 would just be -1, u to the 3/2. And then -1/2 times -2/5, the 2's would cancel. The negative and negative would make a positive, so actually that would be positive 1/5 u to the 5/2. And then just substitute in the u. And then Max said he substituted a little bit differently and got the same answer. So he's just going to put his under and show you maybe something a little different.
Let's see how different it is. What's up, guys? Who's all listening to this? Jake and... Yeah.
But he's missed for so long.
So what? What's up, Jake? So, pretty much, I said the same u, and then I learned, like, just pretty much didn't do the final step. I just said x squared is equal to 3 minus u.
So you did the x and the x squared.
Yeah, so I separated them, because I knew that du is equal to -2x dx, and so I multiplied both sides, or I multiplied by -2. I ended up getting the same step right here, but then it was different, like right here. But Jack and I did it differently, and we thought it was kind of cool, yeah, how like I split it up, and we still ended up getting the same answer. I went kind of potato mode because I had I thought -1/2 times 2 was equal to -1/2 for some reason. And I also thought -1/2 times -2 over 5 was equal to 1 over 10, which didn't really make sense. But I pretty much just did it slightly differently because I just pulled that out, and then I said x squared equal to 3 minus u. So I pretty much got to the same point right here, but I just did it differently. Yep.
That's good. But you found your way. That's the key thing.
Yes, ma'am.
All right. Okie dokes, very nice. So, the next problem that we're going to do is finally a trig substitution. So the thing is, they're not that bad, but they're going to tell you what it is. So this says integrate with respect to x, and if it's an IB problem, they're going to tell you the substitution, but they're not going to tell you the substitution if you're in the homework. Okay, but they will on the IB test and the IB practice questions that I give you. So since they didn't tell me, I'm going to have to figure it out, okay? And you're going to have to figure it out on your homework, but you're allowed to look at your little cheat sheet. And you don't have to, like, memorize the cheat sheet or anything, okay? So we got the square root of x squared minus 4. So if you look over here, we're going to kind of try to figure out what we're doing. Okay, so that looks like a secant. And so the way I want you to figure that out is actually looking at this sheet. Okay, but if it's on the test, I'm going to tell you the substitution. Okay, now it doesn't say a U substitution. Do you notice it says x equals? Okay, they can use whatever letter they want. But because it looks like this, we're going to say it's x equals a secant theta. I'm just going to write that. Okay, but they were doing it like, let me just write that. If it was like this, then they said the substitution would be this. Okay? And again, that means I'm going to tell you, and actually IB is going to tell you what the substitution is when you get there. So for me, it'd be x equals, what would my A be? A 2. Okay, so this substitution would be given to you. They would say, use the substitution x equals 2 secant theta and integrate with respect to x. Okay, so that would be given. What is the thing I told you without any context was the first thing you need to do? Draw a triangle. That's what we're going to do. So what you do is you solve this for whatever the trig function is. So secant theta, I'm going to get by itself, is x over 2. And that's what I'm going to use to draw a triangle. Yes.
Is there a SOHCAHTOA type thing for like secant?
There's not, but I just do it like a reciprocal. So, so if you do SOHCAHTOA, okay, so I do it as some old horse came a hopping through our alley. Yes, I know there's one about a hippie, but I don't know what to tell you. I'm a G kind of gal. Okay, I'm rated G. All right, the reciprocal functions, like if it's at, this starts with an S, the reciprocal function starts with a C, and that's the cosecant, and you just flip this, and then secant. So notice the reciprocal functions, like the C goes with the S. It's not like the C's go with the C's. Okay, and that's the flip of that. And nobody's going to mix up tangent and cotangent. I mean, it's what they get mixed up is like, does cosecant go with sine or cosine? And they're not, the co-functions are a different thing. Okay, so these are called reciprocal functions. And when you get like all crazy, like why they do all these names, but like if you have sine and cosine, those are co-functions. So like secant and cosecant are co-functions. Tangent and cotangent are co-functions. And the co-functions, it's like the sine of theta is equal to the cosine of 90 minus theta. So their complements are equal to each other. And that works for any of the co-functions that go together. So like the secant of theta would be equal to the cosecant of 90 minus theta. So that's the, you know, that's why they've got the co stuff, sine and cosine, secant, cosecant, tangent, cotangent. But well, the way I remember the reciprocal functions is after I do my SOHCAHTOA, I'm just like the C's go with the S's. And then tangent, cotangent's good because it's the same whether it's reciprocal or... Okay, so with that being said, secant is hypotenuse over adjacent. Okay, and so I'm going to put hypotenuse here and adjacent here. Okay, so as soon as you see the trig function, substitution, you're going to draw a triangle. So if I had some kids that didn't draw a triangle in trig substitution, then I know they didn't have a place to plant their foot. Okay, so they said that was one thing that would be helpful if I just really reiterated that you should do that at the start of any problem like that. Okay, now you're also going to solve for the unknown side. How am I going to solve for the unknown side? Yeah, so I'll just kind of do that up here. 2 squared plus, I'll call this unknown side b squared. And I'm going to solve for b squared. So that'd be x squared minus 4. And then b would just be the square root of that. So this unknown side is the square root of x squared minus 4. Now, if you notice, that's in the problem. Okay, so there's a reason that secant kind of helps us out on that. Okay, so we did that. Now we've got what x is. We're also going to find what dx is. So starting points to this problem, plant your feet. You're going to draw a triangle, you're going to solve for the unknown sides, you're going to have x and dx. Yes?
I have a question.
Yes.
Does the A that we like solve for, does that relate to adjacent in any way? Because you use that A for like the adjacent side.
I mean, I get you, but I don't think it stands for adjacent, but it definitely works for the secant. So, I mean, they tend to use A for like constants like they did in the other ones. So, I don't know actually if it always comes out to be adjacent or not. We'll find out. Because this is secant. We'll see what it does on the other two choices. I don't know. Never thought of it. I mean, it could be. All right. So, the question is, what's the derivative of secant? Secant tangent. So, we got secant theta, tangent theta, d theta. All right. So now what we're going to do is substitute into this guy. Okay. So right here, instead of the x, I'm going to put, can we go ahead and square that? Like, instead of 2 secant theta, just put 4 secant squared theta? I got a yes from Catherine. That's all I need. I'm basically going to change this all to be in terms, instead of like in terms of u and du, I'm going to change everything to be in terms of theta and d theta. So right there, instead of x squared, that would just be 2 secant theta in parentheses squared. So I'm just squaring the 2 and getting 4, and squaring the secant and getting secant squared. Okay, now I've got to put in for dx. Like, what a ripoff. I had a cute little dx, and now I got to put all this. I mean, you know. Okay, and then x in the bottom was just 2 secant theta. So already I'm like kind of impressed with you. You made it this far in the problem. I mean, it's your first one. But like, if this was the test, I'd be pretty impressed you got it to here. Okay.
Wait, what? On a test?
On a test. Getting to here means that you understand what the process is. Okay, just trust me on this. You get half the marks if you make it this far. All right. So, see anything good to do?
Yeah,
I mean, why not get rid of that? I mean, there are people that didn't make it this far. They didn't draw a triangle. I mean, how are you going to get very far if you don't draw a triangle? It's trig substitution. Yeah.
So, kind of like, I was a little confused on when you drew the triangle, how you know what the
Okay, so I took the substitution that they made me do. Okay, so, well, they're going to give me this. X equals 2 secant theta. So if I solve that for secant theta, then that would be x over 2. So I'm going to draw a triangle such that its secant is x over 2. Is that better? All right. Now, does this little 4 secant squared theta minus 4 look like anything? Well, isn't that what we did? Oh, she's never minding. Oh, I don't need a denominator anymore because I canceled my denominator. It does look like a trigonometric identity. Okay, here's what I'm going to do. I'm going to factor out the 4 and see if it looks better to you.
Oh, you're kidding.
I'm not even kidding.
Whoa. You're kidding me.
Okay, so remember the formula sheet is your friend, okay? Alright. So if I look, let's just say that I didn't have a kid that already knew everything. I would go back to my little formula sheet under trig. And I would be like, huh, that looks like something. So 1 plus tangent squared is secant squared. So secant squared minus 1 is, in fact, tangent squared.
If you were off,
Am I?
That one is tangent squared theta.
See, next year you're going to be like, when the juniors go to this day, you're going to be like, this is some good stuff coming your way, kids. Just get ready. Alright, so taking the square root of 4, you get, taking the square root of tangent theta, same as square theta, yeah. Alright, so 2, I'm just going to take it out. Now I have a question for you. Do I know how to integrate tangent squared?
No.
Is there anything that I do know how to integrate?
Secant squared theta.
Do you know how to do secant squared? Because what's the derivative of tangent? Secant squared. So the integral of secant squared is tangent. So I would really rather this be a secant squared and not a tangent squared. If only there was like some kind of trig identity for that.
Why did we change it at all? Yeah, why did we change it if we just changed it, right?
Because we needed to know we could take the square root. Like I couldn't, I mean, I can't just look at that. I mean,
That's true.
see, I didn't, if you think about it, right, I had to know I could take the square root and it come out perfect. So I kind of had to go that way. It wasn't like I took you down a path we didn't have to go. All right. So tangent squared is secant squared minus 1. But see, I got that from a combination of this and this. It wasn't like I just changed this back to what it was. Okay. So tangent squared, I'm just going to put another piece of paper. I'm trying to show lots of steps, so we said was secant squared theta minus 1. And so that I don't make a careless mistake, I'm going to divide that up. So I'm going to do the integral of secant squared minus the integral of 1. Okay, and when we integrate secant squared, we get minus theta. And this, I mean, this looks, I'm going to go ahead and distribute. You're probably feeling pretty good about yourself right now. I know I am. We've integrated. But look at how the problem started. It was in terms of x.
Oh, goodness gracious. What in the world is a theta?
I don't want an answer in terms of theta. But it's okay. All we got to do is go back to our triangle. Okay? This is the triangle who had a secant of x over 2. Okay? So I can find the tangent of theta from my triangle. So tangent's a ratio of opposite.
It's b over 2.
Yeah. So, well, opposite over adjacent, that over that. So, okay. So it's going to be the square root of x squared minus 4 over 2. So you just go up to this and find the tangent. Opposite over adjacent. Okay. Now, theta, you basically can change it to an arc trig function, like any trig function you want. I tend to change it to like whatever I started with because I'm less likely to mess it up. So if secant theta is x over 2, theta would be the arc secant of x over 2. So that's what I tend to do. You could do it, if you hate arc secant, you could do the arc cosine of what? 2 over x. You could flip it. You could do any combination of this. Okay, you could do the arc tan of this over this. But you literally change it to anything. I tend to go back to whatever I was given so that if I solved wrong. Cosine I like a little more than secant. I don't know about you. So what do you want to do? Arc secant or arc cosine? Okay, so arc secant of x over 2 plus c. Now, they have to allow you to do any trig function you want here. Okay, so if your answer is different than the back of the book, but you don't even have a back of the book for these because I gave you a little piece of paper, then you don't have to worry. That's it. You made it through your first trig
So
problem.
you can leave it there.
Yeah, that's it. Yeah, it's back to x's. That's how you know you're done.
I don't like it very much.
I hate it.
I mean, it's pretty sophisticated. All right.
I think next week is going to be math.
All right, so here's our next one. It's not too bad. You're what? What?
Jack's.
I don't think so.
Could you even drop to math studies?
No.
if you were a jump?
No way.
What if you cry?
No way.
Like, I feel like I could get a 7 on the math studies test right now.
Actually, you couldn't. And the reason is they do some statistics stuff that we don't even do in HL, but it's not, I'm not saying it's difficult.
So they're
But like, let's say they do a chi-squared test. We don't do a chi-squared test. We do tons of stuff they don't do, but they do some stuff we don't. Exactly.
Are we gonna do a chi-square test?
Never.
What's a
It's not in our curriculum.
wait, so the math studies people are above.
No. They do some things that are different than us.
We restore our pride and then the chi-square.
I mean, we did it in teams one year. Anyhow. Okay, look on your sheet. But that's like a whole other story with this crew. So take a look at this. See the x squared plus 16? Because for today, you got to use your little cheat sheet and figure out. Okay, so that kind of looks like this one, right? Okay, and again, I'll tell you on the test, but not on the homework, so you use this. You don't want to do this? Is that what I just heard? So x squared plus a squared, it says I should do x equals a tan theta.
Before we say like on the test, you'll give us like that chart that'll show us.
I'm not going to give you a chart. What I'm going to give you is use the substitution x equals 4 tan theta. I would give you that. I will.
Just skip the step of
Yes, they just actually tell you the substitution. It does. So you don't have to worry about that part, which I really, really like. Okay. Okay, so we know the substitution, which will be given to you on a test, but not on your homework. Use the chart on your homework. What is the first thing you do when they give you a trig substitution? All right. You are going to make mincemeat out of the seniors. I'm telling you. So you're going to need a theta, and you're going to solve this for tan theta. So tan theta would be what?
4x over x over.
Okay, and tan is a ratio of opposite over adjacent. Okay, so you are making an angle such that its tangent is x over 4. We should. What do you think the hypotenuse will be? Okay, what do you know? That's kind of over here. So it kind of makes me feel good, like I'm on the right track if some portion of that's back in there. Alright, so I'm feeling good. So I got x, what else do I need?
dx.
dx, good plan. Alright, talk to me about it.
4 equals to 1.
D theta. Okay, so now you're going to go to your problem and change it all to thetas and d thetas. Okay, so here we go. 1 over x, so that's, alright. And then, can I go ahead and square it? So that'd be 16 tangent squared theta plus 16. Can I put the dx in the numerator, or do you need it to the side?
Put them aside first and then.
Okay, I've got at least enough votes for the numerator because I just don't have the room. Okay, so this is my problem. If you want to write dx to the side, you would just have 1 in the numerator, but I just didn't have room, so I put it in the numerator. All right, talk to me.
Well, should we distribute?
Anything easy, like an easy something? Well, I just wanted to cancel the 4s.
16.
Yeah.
Could you explain how you get all that stuff in the
Yeah, that was the dx. So, like, I could have written this. I just didn't quite have room. So I could have written this like 1 over 4 tangent theta, 16 tangent squared theta plus 16. And then dx was all that stuff. And it was just, I didn't have room to the side, so I just wrote it in the numerator. Okay. Okay, so that didn't do much. Thoughts? What about the denominator? Do you see any kind of trig identity lurking? Yes. You can even take it like all the way out of the problem, like out here if you want. But yeah, it would be. Okay, so tangent squared theta plus 1. It's already solved, is secant squared. This is looking kind of nice. You want the 16 out? Ooh. It's looking kind of nice. Yeah, let's get rid of those secant squared thetas. I think ln could be useful, but why? No. Because what's the derivative of tangent? Secant squared. You don't have your du. What do we sometimes do to tan? Sine over cosine. So if it's 1 over tan, what would it be? Oh my goodness. I don't know how the seniors don't love this right here. This is failing crazy-tastic. Okay, what good is that? Yeah, I do know, but do you know? So what do you think you should be? Yeah. Use the denominator. Do you? This is just a good time.
So now we're into the U's. Okay. It's equal to 1/16. Now we're with U. 1C, and I think we're going.
You think wrong.
So how many points do I get if I stop here?
Not enough. You want to go. It's like you're 35. You're not stopping there. You're going for 36. All right. By the way, just for so you know, I got 27 on ACT, so that's okay. My daughter got a 36, so that's why I can say all these things.
What did your son do?
That's none of your business. So there you go.
I'm sorry.
All right, so here we go. ln of, I mean, if it was a 36, you would have heard about it. So if it's anything other than a 36, why would he want to be compared? You see?
Fair enough.
Okay, there you go.
I've never met your son.
He's fan-freaking-tastic, and he's going to be home today.
Yeah.
Yep, spring break. Absolute value.
How old is he now?
What do you think? 21.
You got a 21 on his ACT?
Get out of the way.
All right.
I've seen him in like 10 years.
What college did you go to?
He's at UT. He's graduating this year. One out, one in. Yeah, so I'll still be working here, if you're wondering. Don't worry, I'm not going anywhere. All right, so absolute value of u. this isn't that as bad as we think, because we've integrated everything.
X squared plus 16.
Once we finish, we just have to make sure it's back to x's. The only thing to fix is sine of theta. I can do that. No, I don't. I'm not going to do that. You could, but you could just go straight for the trig function. Sine of theta is opposite over hypotenuse. So you don't want it to be like too complicated. Okay, so 1/16, the natural log, the sine of my angle is opposite over hypotenuse. So I can just put x over square root of x squared plus 16 plus c. And you got it. That's it.
Like, who are the ones that integrate that?
I mean, me.
They
They pay me every day to do this.
What real life application does this have?
Are you trying to say I'm not real? Actually, if it makes you feel better, as soon as we do this, if you'll notice, all your notes know I got to teach you integration by parts, and then all the rest of your notes are applications before your next test. Applications of integration. So then you'll have a reason to do this.
So then, like, the next test, what applications is going to be like short answer questions of us writing how we're going to use integrals?
Sure it is.
That would make fun of the application of the derivative test. Nobody thinks past
Yes.
Past applications of
Substitution.
Okay, so I went back to my triangle. So sine of this angle is opposite over hypotenuse. So you go back to that. Okay. I think he probably, he went through the first semester and then we decided to change to further math. I don't know why I didn't decide before, but I guess because I haven't ever taught further math. So he does an independent study. But he did the first semester with everybody. But see, he'd had calculus BC. So, as a sophomore, wherever he was before. So that's basically, he'd learned all the calculus of this course. He had known the statistics and stuff like that.
You learned calculus B.
Paulo had calculus AB. And AB is just part of your calculus. It's not all of your calculus. It's like half of your calculus. So, like, you don't skip HL if you've done half of it. Which makes it a little awkward if you, like, seen half of it. You know what I mean?
So is this equivalent to AB and BC calculus?
At all. We're going to save this one. Because, to be honest with you, I can do probably all 4 of those problems on the next page in the time that it takes to do that problem.
That doesn't sound fun at all.
Okay? So I'm going to save that one for next class. Okay? Is that all right with you? No, we need to do that, and we got to do cosecant, something else. There you go. I got to teach you how to do those too, but they're short. Okay, so these are actually short. In fact, none of these are trig substitutions. Okay, so I've only shown you 2. I'll show you one more. You have some in your practice. All right, so we're still got the directions integrate with respect to x. These are short problems. I like it. They suggested to me. Me? If you see an L on X, try making it your U. Sounds like a good plan. If I do U, I need a DU. The audience just told me. Ooh, do I have the DU? Sweet. Okay, so that must be somewhat useful. Okay? I don't think so. I'm going to put for you. So it's going to be kind of weird. You're right that I don't just have DU because I got all this junk. So something's up. Let's see what's up. Okay, so 1 over x dx, you agree that everything circled in red, I can just call that du? Okay, so I have a 4. I have ln x, but that ln x is u. So that's okay. And then 1 plus ln of x is just u squared. Now I need you to think about this. How do you think? If I had just given you this, let's just pretend fresh. Boom, here's a new problem. What's your thoughts? It is a u substitution. What would the u substitution be? Yep. Because Isn't that kind of cool? Okay, so it's another U substitution.
It's not you.
It can, so pick a letter.
MD.
D.
Why?
I'll do it under.
Make it a W.
M.
Okay, W.
Yeah.
I like that. It's like a W. Yeah, we're doing W substitution. You need a W. I like it. That's it from now on. Like that's what the juniors are doing. Just say.
We gotta come out with kinds of rule.
And it's a W.
Yes.
How much better can you get? That's it. It's done. Done deal. You just scored. I like it.
Alright, write it down.
I don't have to write it down. It's all up here. Till I leave, then I don't know what they're going to do. All right, so what's DW? Oh, and it's cool because it's Arthur's sister. I mean, this just has so many pluses to it.
Arc. You never seen Arc with the Arc card with mustard? Go back to mustard.
And I say, hey. Oh my gosh, I go home and start watching episodes. All right.
It was on Netflix. What?
I mean, it's pretty important. All right, so I'm looking to see if I have DW.
We needed other two.
Well, no, I got more 2s than I need. Yeah, so I'm going to take out a 2. I'm going to go up here somewhere. So I'm going to write it like this. Okay. Because I really only wanted 2 UDU, so I had like an extra 2 I didn't want, so I pulled it out. This is good stuff right here.
Whoa. Why did we put a 2 on the inside?
We only needed 2U on the numerator.
So you multiply 4 by 1/2. Put that 2 reciprocal.
Oh, I see. Never mind.
So 2 ln absolute value of W plus C.
There's 2 minutes.
What on earth was W?
W was 1 plus U squared, but that is 1 plus ln x.
You want that in 1 step or 2?
2 steps. Come on. Jake's trying to learn here. Come on, guys.
Oh, Jake's trying to learn, they said. Jake loves to skip steps.
Okay, let's take bets on how much of this video Jake watches. 'Cause I bet
Zero.
I bet
Let's
zero
just
on
take
top.
bets on if he's going to watch the video.
I bet he doesn't.
He's not gonna watch the video. I can guarantee you.
Just put a code word at the end of the video.
Jake's gonna turn Paul on us and just go missing.
I think you need to plan it in the middle of it. Because at the end, you might just fast forward the end to get the homework, but like if we plant the code word in the middle.
But if you got expelled, then you just keep telling us.
It's medical. He's listed as medical. We did not expel him.
Dang. No, I'm I love Jake.
We're hoping that
I
he's
would
getting
Jake
better.
would just care more about school. He said dreams and aspirations.
You used to say you wanted to go to MIT.
He used to be so motivated.
All right, thoughts?
Then he got 35 on his ACT. Failed the first one last year.
Thoughts? Looking for thoughts. Anything scream at you about this problem or irritate you or...
Well, I don't like that it has X and 2X.
Okay, I don't like that it has X and 2X either.
It's screaming to me that we want to take the derivative.
This is an integral problem. Okay, now I don't like it because, I mean, sometimes I like it with sine and cosine because, like, the derivative of sine is cosine, derivative of cosine is negative sine, but the problem is the mixture of x and 2x, like you already pointed out. So, I'm going to go look at my double angle formulas. The only bad thing about this is I have, like, 3 choices.
3 choices.
Yeah, look, cosine 2x. It could be cosine squared minus sine squared. It could be 2 cosine squared theta minus
So we
1.
choose the one with the sign.
There's 2.
Okay, so if I do the one with the sine, then everything's going to be in sine.
That's your son.
If everything's in sine, I'm not going to have a du. I'm going to use the cosine one. So I'm going to use 2 cosine squared theta minus 1.
Wait, how did you come to that conclusion?
Gotcha. Hang on, let me just write it. And
I
then
have a
I'll...
question. No, lost my question. Never mind.
That's okay, because I already have a question to address. So the question is, because I was trying to look at the formula sheet too. So the question was, why did I choose 2 cosine squared minus 1? Well, if I changed it to all sine squared, so if I picked the one that was 1 minus sine 2 sine squared theta, then I would have all sines in the problem, and including sines to a power. And the derivative of sine is cosine, and have no cosine in it. So I really wanted it to end up with a mixture of sine and cosine, so that when I use like the power rule, I'll have a du out here. And then the sine squared minus cosine squared was just going to mix me all up. I needed it to kind of go all one. And you can kind of try trial and error, but it kind of helps to have the derivative of the inside as a general rule. So what I'm going to do is I am going to distribute and separate. So I'm going to have the integral of 2 cosine squared x sine x minus the integral of sine x. And they both have dx's. Oh, and I'm going to zoom out a little bit. Well, let's do the easy part first. What's the integral of sine? Yes. So this would be minus a negative cosine, or just a positive cosine. Okay, what's your thoughts on this guy? So what's u? Du? Do I have it? Almost. So I'll just put a negative there and a negative there. Okay, I'm going to need to take the 2 out. I don't know, would you rather me write that as -1 times -2, or getting absolutely no comment on that? So this would be -1. Do you want to bring the 2 out right now?
Yeah.
Okay, so -2 integral of u squared, and this negative and the sine x, all of that's your du. And then plus cosine x plus c. And then that's just power rule. So -2 1/3 u cubed plus cosine x plus c. So -2/3 u was cosine x cubed plus cosine x plus c. Oh, sorry. Let me do some stuff here. The next 2 problems are just like 2 lines each. They're like super short. Okay. So, any thoughts on the next one? It does look like an arc sine. You are correct, my friends. Okay, so I'll just write the rule over to the side. So, I mean, you should have your formula sheet out when you're doing this. And see, the problem is that could be a trig substitution just because you see that. That's part of why they tell you, I think. Because there's a limit to how much time you have to try stuff. So you're kind of looking for 2 things. One is, can I go straight to an arc sine or an arc tan? And if I can't, then what substitution am I going to make? So this one, really all I have to do is rewrite it. X over a plus c. Okay, so this is 1 over the square root of a squared minus x squared dx equals arc sine x over a plus c. Okay, so if I wrote this, it would be, basically you're writing it like it's 3 squared minus 2x squared. So that way it looks like a constant squared minus some kind of variable expression squared. And so we don't just have a and x, we do just have a. What's a? And we're going to have to do a u substitution because it's not x that's being squared. So u is what? And du? Do I have it? Okay, so if I rewrite this now, it's 1/2. This part's the du over the square root of a squared minus u squared, which is just the rule. So it would be 1/2 arc sine u over a plus c, and then just substitute in your u and your a. So 2x over 3 plus c. You've done really well. We have one more, and you'll be done. Yes.
With the majority of the problems on like the hard tests, this is going to come up be like this, or be like the problems on the table?
Actually, there's on the next one, it's a lot of applications. It's just, I know they had maybe either 1 or 2 of the trig ones, and that like threw them for a loop. And then a lot of the application ones are not that bad. I can't remember if that's the test they didn't pay attention. I know on the derivatives test I reminded y'all about how you could use the calculator for some stuff. I don't know if it was a similar problem on that one, but I'll look at it when we get there. We've got quite a while to go because we got to do a lot of applications. It's not just all straight integration, because you already had one kind of like that. So, okay, last one. Last one. You've done really, really well. Lots of listening to me. Does this look like anything? Yeah, almost. I mean, I'm almost tempted for you to be ln of x, except this kind of looks like a constant squared, then plus an expression squared. So it kind of looks like an arctan. Okay, so I'm going to start this by just writing it like 3 squared plus 2 ln of x squared. And I mean, that's a little annoying because a lot of times ln of x is a good choice for you. But this one almost looks like arctan. And this 1 over x is really just part of the derivative of that. Okay, so you need to see the arctan rule to kind of get a picture on that. I'll just write it somewhere. I don't know where. Yes. So this is just the rule.
It's not a squared plus x squared.
Yeah. And you definitely want your formula sheet. Can you read that at all? Okay. That's a dx. I know it doesn't look remotely like it, but that's just the rule. Okay, so for me, what's my a? What's my u? What's du?
2, 1 over x. 2 over x.
Okay, so that's almost it right there. I just need a 2 and a 1/2. So if you rewrite this, it's 1/2 the integral of du over a squared plus u squared. So it's 1/2. I'm going to, since it's exactly the rule, can I just write this and put in the a and the u? Okay, I got approval. 1 as soon as you lose. 1 over 3 arctan 2 ln x over 3 plus c. And I feel no desire to multiply through the half. You can. You can make it 1/6 if you want. And that's it. And your homework is to try to do the problems on that sheet. I would, yeah.